everyone. For today's lesson, we are going to continue our conversation about proving properties of parallelograms using coordinate proofs. In this lesson, what we are going to do is instead of just working with parallelograms, we are now going to be working with rectangles, rhombuses, and squares. So what's going to happen is I'm going to give you a property and I'm going to tell you exactly what shape it is. And you are going to use the coordinates that are given to you and you're going to prove that property. So in like letter A, I'm telling you that this is a rectangle, and you're going to prove that it has 4 right angles. So remember, let's go ahead and look back at our vocab video to remind ourselves of what formula we should use in order for us to accomplish our proof. Remember that if you are asked to prove something is congruent, either sides are congruent or diagonals are congruent, we are going to be working with the distance formula. So when you see that word congruent, we always use the distance formula, and you would want to show that segments have, or side lengths, have the same distance. If you are asked to show that opposite sides are parallel, or if you want to determine whether or not a shape has right angles, that would indicate that you would have perpendicular lines. You would need to use the slope formula. So let's say that you wanted to show that opposite sides are parallel. That would mean that you would need to show that some sides or opposite sides would have the same slope. If you want to show that, or decide whether or not the angles form right angles, like we have and you want to determine whether or not you're dealing with a square versus a rhombus, for example, you would analyze the slopes. If you notice that the slopes are opposite reciprocals, that means that they have the same numbers, but one is positive, one is negative, and the fraction has been flipped. So we flip the fraction, switch the sign. That is an opposite reciprocal. If you notice that, then that means you have right angles. If that relationship doesn't exist, then that means that you do not have right angles. So we use the slope formula a lot for that determination. And finally, if you want to show that the diagonals bisect each other, you're going to be working with the midpoint formula. And you would want to show that the diagonals, for example, have the same midpoint. So it all just depends on what we are asked to prove. And like we saw in letter A, we are told that we have ourselves a rectangle. And a lot of times these shapes are going to be pretty obvious. Clearly this is a rectangle, but we want to show that it has 4 right angles. So if we want to show that they have 4 right angles, that indicates that we need to be working with the slope formula, and we need to show that consecutive sides, consecutive means that the sides that touch, have opposite reciprocal slopes. That's what we need to show. And whenever we do a coordinate proof, we always start off by identifying the formula that we plan to use. And so since we're working with slopes and we want to analyze their slopes, we're going to be working with the slope formula. So I'm going to write m equals y2 minus y1 divided by x2 minus x1. This is a requirement for all proofs that you need to make sure that you identify that formula. From here, let's go ahead and analyze all of the slopes. Preferably, I would recommend that we identify, opposite side slopes just to show that these slopes are the same, and then we'll analyze the slopes that are touching. So I like to do yellows and greens, or like identify slopes in 2 different steps. I find that to be really helpful. So let's go ahead and start with finding the slope of WZ. So I always use lowercase m, and I'm going to identify the slope of WZ. And what I'm going to do is I'm going to use that formula of y2 minus y1. So that's going to be 0 minus 0 divided by x2 minus x1, which is 4 minus 0. And all I'm doing is using the ordered pairs down here for WZ. If it helps to label, go ahead and label. But for time purposes, I'm choosing not to label this time. So this is going to be 0 over 4, which is 0. So now I'm going to identify the slope of my other yellow side. And my other yellow side is x y. So I'm going to find the slope of xy. So that's going to be 2 minus 2 divided by 4 minus 0. So that is 0 over 4, and once again, that's 0. And what I noticed is that these two sides have the same slope. These opposite sides have the same slope. So now let's go ahead and look at our slope for xw. So that is going to be 0 minus 2 divided by 0 minus 0. So that's going to be negative 2 over 0. And we knew that whenever 0 is on the bottom, it's no way, and that is undefined. Okay. Next, we have the slope of yz. So that means that we have 0 minus 2 divided by 4 minus 4. So that's going to be negative 2 over 0. And once again, that's undefined. So my slope of my green sides end up being undefined. So now I don't see opposite reciprocals. I don't know about you. I see a 0, I see an undefined, I see 0 on the bottom versus a 0 on the top, but I'm not seeing that opposite reciprocal like we had talked about. And that is because there's something that I need you guys to know. And that is because that is the slope of vertical lines compared to horizontal lines. In this problem, we have horizontal lines, and horizontal lines have 0 slope. Undefined slope come from vertical lines. And whenever you have vertical lines and horizontal lines, they automatically are perpendicular to each other, regardless of whatever number you're dividing by. Vertical and horizontal, that's how our walls are staying up. They come together, they form right angles. So even though we don't have necessarily opposite reciprocals, what I want you guys to note is that 0 slope and undefined slope are always perpendicular. So I'm going to write that up here. 0 slope and undefined slope are always perpendicular slopes. They are always perpendicular slopes. So that is something I need you guys to know and study. They will always form right angles. So since, what we're going to say is since WZ, slope or segment WZ, so this is this slope down here, or this line down here, is perpendicular with WX, and WX is perpendicular to XY, and maybe I shouldn't put so many ands because that's not correct English, and the XY is perpendicular to YZ, and segment WZ is perpendicular to YZ. Therefore, a rectangle has 4 right angles. So what I was saying is that I'm taking all of these slopes, and what I'm noticing is that 0 would match with an undefined. They would be perpendicular, 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 perpendicular. So an undefined slope would match with a 0 slope. And so I was just going all the way around just to say that all of these angles would be right angles since all of the side lengths would be perpendicular to each other. All right, let's go ahead and look at letter B. Letter B says a rectangle has congruent diagonals. So when you see that word congruent, that means that we're going to be working with the distance formula. So we want to show that the diagonals have the same slope. I'm sorry, have the same length, excuse me. So we want to show that the diagonals have the same length. So that means that we have to be working with the distance formula. That is x2 minus x1 squared plus y2 minus y1 squared. And the diagonals are not drawn in. And a lot of times kids get very confused because I'm asking you to talk about diagonals. So maybe what I should emphasize here is the word diagonals and not just opposite sides, but we are working with the diagonals. So let's go ahead and draw those diagonals in. So you might need a straight edge, like you can use the side of a cell phone, a book, anything. Truly, we just want to draw in those diagonals. And then I'm going to color coordinate them just so that we know what we're talking about. I'm going to call this one the orange one, and I'll call this one the green one. All right, so let's go ahead and look at the length of our orange one. So that's WY. And I don't have a line above it because of the fact that I'm talking about distance. So WY is equal to the square root of, and if it helps to label X1, Y1 and X2, Y2, go for it. If it doesn't, then don't worry about it. So I'm working with WY, and that is the orange segment. So I'm going to write 8. So that's X2, which is 8, minus X1, which is 0 squared, plus Y2, which is 3, minus Y1, which is 0 squared. So 8 squared, so 8 minus 0 is 8. 8 squared is 64, plus 3 squared, which is 9. 64 plus 9, that is equal to 73. 73 doesn't have any perfect square factors to it, so we're just going to stop right there at 73. Next, we're going to go ahead and look at the length of XZ. XZ is the green segment, so that's the one that I had labeled in green, and I'm going to be using these ordered pairs of 0, 3, and 8, 0 to help me to find the distance. So if you want to label, you're welcome to label. If you don't want to, that's fine too. It might be helpful for you to do so. But I'm going to write 8 minus 0 squared plus 0 minus 3 squared. So 8 minus 0 is 8. 8 squared is 64. 0 minus 3 is negative 3. Negative 3 squared is 9. And once again, we end up with 73, the square root of 73. So both of these segments ended up being the same length. So therefore, our conclusion is going to be since, so I didn't give you the sentence stem this time, so I want you to now figure this out. Since segment WY is congruent to segment XZ, so these were our diagonals. Since our segments have the same length, so therefore they are congruent, therefore, rectangle WXYZ, I like to call it out for what it is. So this is WXYZ, has congruent diagonals. And that is just me rewriting what we were trying to prove and talking about what we noticed. So since we see this, therefore, we have proven that this rectangle has congruent diagonals. Let's go ahead and look at example number 2. In example number 2, it says, write a coordinate proof to show the following properties of a rhombus. So you want to remember those properties of a rhombus. So this is a picture of a rhombus, and we want to show that it has 4 congruent sides. So if we're dealing with that word congruent, that means that we want to show that all sides have the same length. So that means that we're going to be working with the distance formula. But this time we're not working with diagonals, we're working with all sides. So that distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're just going all the way around, so I don't really need to color coordinate. Maybe I'll color coordinate as I find the distance of a side. So I'll start with WX. And you can label whichever way you would like. I'm going to go 0 minus 3 squared plus 0 minus 4 squared. That's going to be equal to 0 minus 3 is 3, negative 3. Negative 3 squared is 9. Plus 0 minus 4 is 4. 4 squared is 16. This is the square root of 25. Square root of 25 is 5. So this length is 5 right here. So now I'm going to identify the length of XY. So I don't know why I put W next. So I'm going to go all the way around. So I'm going to find the length of XY next. So that is going to be 8 minus 3 squared plus 4 minus 4 squared. So that is equal to the square root of 8 minus 3, which is 5. 5 squared is 25. 4 minus 4 is 0. And I don't need to write it down because I know that 0 plus 25 is 25, and the square root of 25 is 5. Cool. So now I'm on to my next side. My next side is YZ. Let me find that distance. So you can label it whichever way you would like, but I'm going to go 5 minus 8 squared plus 0 minus 4 squared. So this is equal to the square root of 5 minus 3 is, 5 minus 8 is negative 3. Negative 3 squared is 9. 0 minus 4 is negative 4. Negative 4 squared is 16. 9 plus 16 is 25, and the square root of 25 is 5. So far, I'm doing really well. I've shown all of these lengths are 5, and I just have one more left, and that is WZ. So let's go ahead and find the length of WZ. And I'm going to write 5 minus 0 squared plus 0 minus 0 squared. 5 minus 0 is 5. 5 squared is 25. 0 minus 0 is 0. I don't need to write that under there because I know it's just going to give me a 25, and I know that the square root of 25 is 5. All of these lengths ended up being the same exact number. It ended up being 5. So what we're going to write down in our conclusion is since the segment of WX is congruent to segment XY, which is congruent to segment YZ, which is congruent to segment WZ. So all I did right here is say that all of these segments are congruent to each other since they have the same length. Since they are congruent to each other, we can therefore say that rhombus WXYZ has 4 congruent sides. Which technically this should be FOUR, but 4 is fine. So 4 congruent sides. And that is our statement. All right, you guys, what I would like you guys to do is I want you to pause the video, and I would like you to please go ahead and do example number 3, letter A. Example number 3 on your own. This is all of the properties of squares. So we talked about rhombuses, we talked about rectangles, and now we have example number 3. And I would like you guys to please go ahead and do example number 3 on your own. And then we're going to talk about example number 3 together when I see you guys in class. I think you have all of the information that you need in order for you to answer all of these questions, but that is the end of today's lesson. If you have any questions over anything, once again, please feel free to email me. Otherwise, I hope you have a wonderful day.